Offermann, and I'm happy to present you today an overview and the main findings of the study Role of Building Automation Related to Renewable Energy in Nearly Zero Energy Buildings, which we, as Ecofys, have elaborated by order of Leonardo ENERGY. For sure, there are several backgrounds to consider for this topic. I just want to pick out two facts. Against the required energy-saving trend, the electricity consumption in the European non-residential buildings has increased by 74% over the past 20 years. Furthermore, as from 2020 onwards, according to the EPBD, all new buildings have to be so-called nearly zero energy buildings. What that means, I will discuss later on. This examination will focus on building automation in non-residential, nearly zero energy buildings. Arising from this background, the examination should bring light on the following questions. The first question asks, are there special types of buildings which offer to benefit best from building automation? Second, which type of energy demand or which types of renewable energy are most suited to control? And the last two, what can be done to help policy towards regulation regarding building automation to firstly reduce the energy demand of future non-residential buildings significantly, and what can be done to optimize the use of renewable energy? To solve these questions, it is necessary to understand the energy demands and flows of non-residential buildings, which are in focus of this study. Compared to residential buildings, non-residential buildings consist of a significant share of electricity for lighting, ventilation, and cooling, but also for equipment, which is not considered under the EPBD. A look on the different non-residential building types shows that, firstly, low shares can typically observe for buildings which often consist only a very simple technical equipment like schools or hotels. Higher shares of electricity can be observed for buildings with a high lighting, cooling, or ventilation demand. A typical example here is a supermarket. Office buildings are somewhere in between, having an electricity share compared to the total building-related energy amount of about 30%. You should consider that those figures relate to existing buildings. Considering nearly zero energy buildings, this picture will change, as we will see. But first of all, the question, what is a nearly zero energy building? According to the EPBD, European Performance Buildings Directive, a nearly zero energy building is a building that has a very high energy performance. The nearly zero or very low amount of energy required should to a very significant extent be covered by energy from renewable sources, including renewable energy produced on-site or nearby. So that is the official definition from the EPBD. You see, the expressions nearly zero and very low leave a lot of room for interpretation. But at least the nearly zero energy buildings have to be cost optimal over a period of 20 years. Also, although the national definitions are mostly still not fixed in detail, it will be sure that on average the energy demand of new buildings will need to be reduced significantly. What that means for the shares of energy demand is illustrated in the following picture at an example of a 3-story medium-sized nearly zero energy office building at different locations in Europe. Independent from the climate, the heating and cooling demand is less than 50% of the total building-related final energy demand. Including appliances, without considering heat pumps, more than 70% of the required required energy is electricity. As you see, the role of heating and cooling demand is not more outstanding as before, and now in the same range as the demand for lighting and ventilation, controls and pumps. Regarding renewable energy potential on-site, the picture also indicates the achievable PV yields, considering here 30% roof coverage in the different regions. Considering an annual balance in Northern and Central Europe, about 50% of the building-related energy demand can be covered by PV. High direct PV coverage rates can be reached for cooling, for ventilation, and appliances. In southern regions, the annual coverage can reach 100% and more, surely only when considering an annual balance, for sure. From the picture, it can also be derived that if a significant share of renewable energy from PV should be achieved, the building height should need to be limited to a height of about 3 levels. Besides the only control-relevant renewable energy source on site is, besides PV, the only control-relevant renewable energy source on site is solar thermal energy. Solar thermal energy is especially suitable to cover thermal energy demands during the summer season. Therefore, it is typically used to cover domestic hot water demands, but the domestic hot water demand of the most non-residential buildings is very low. Exceptions are hotels, hospitals, or surely indoor swimming pools. Regarding on-site, wind is not a relevant renewable energy, but off-site, the European electricity grids will have to solve the increasing shares of uncontrolled renewable wind energy. Further renewable energy sources like geothermal, biomass, or waste heat are always available and therefore typically do not require special control to increase their usable shares. To increase the share of uncontrollable renewable energy sources, suitable energy storages are required. There are many types of energy storages for heat or electricity and different sizes from small to huge seasonal storages. I want to highlight here the cheapest one, the thermal building mass. In a nearly zero energy building, the heating and cooling demands will be decreased significantly, but not the thermal building mass. As the solar and the internal loads are in the same order as the heating load, the load shifting potential related to the heating demand gets significant. The increased influence of the thermal mass also allows to increase the share of renewable energy on and off site. Nearly zero energy buildings are very flexible in time of the day when to provide the necessary heating or cooling energy. The use of on-site renewables can be increased, for example, by a combination of PV and cooling. A grid stabilization or a grid stabilizing control is possible by using heat pumps or CHP. Although they offer further potentials for increasing the shares of renewable energy, seasonal thermal storages and batteries are actually not economically feasible. How these technologies and the economical pictures of these technologies will develop in the future, we will see. When summarizing all that backgrounds, what does that mean for building automation? To answer these questions, we have distinguished the main functions of building automation in this context. First, The first considered function is central concerted control of all energy-related components. The second, monitoring and providing feedback. Thirdly, as already highlighted before, we have load shifting and storage management. And last but not least, relevant is also ensuring the thermal comfort. Let's take a look on the potentials of building automation for the different functions, starting with the function of central concerted control. As building systems are actually often controlled individually by central controlling, for example, blinds and lighting in dependency of each other, as well as in dependency of heating and cooling demand, building automation offers saving potentials of up to 50% in nearly zero energy buildings. But there is a but. Although the saving potentials of central control can be huge expressed in shares, as I've done before, the absolute savings at nearly zero energy buildings are limited, what makes the payback usually difficult. Furthermore, it also needs to be considered here at the determination of the potentials that the controls themselves also need energy, which has to be considered. Monitoring and providing feedback. To ensure that there's no gap between calculated and real energy demand, what is essential, achieving the climate targets, building automation is required to discover the differences and to offer possibilities to overcome those. Actually, often huge gaps due to insufficient parameter settings or derivations from planning lead to significant gaps. As one example to mention here is in case of heat pumps, the system temperatures, which have a significant influence on the efficiency of the whole system. Providing the next point is providing feedback. Providing feedback to the user has impact on his behavior or her behavior. The potentials of this can be estimated to be somewhere in between 5 and 30%. The potentials of load shifting in insulated buildings have been discussed in detail before. This flexibility can be used solar and internal loads during the heating season, and you can use night cooling during the summer. With flexible electricity tariffs, the controlled heat supply by heat pumps could offer an economically feasible contribution to grid stabilization. Looking on-site renewable energies, the achievable shares of total energy coverage by PV range from 20% in northern regions to up to 50% in regions with high cooling demands. The potentials of heat demand coverage of on-site renewable energies are small. The coverage rates could be for sure increased when using batteries, but as said before, they actually economically not feasible. The least potential of building automation I want to mention here concerns the thermal comfort. At nearly zero energy buildings with a small thermal mass, only little energy amounts are needed for major changes of room temperature. Therefore, in those buildings, a sophisticated control is required to prevent discomfort. The same accounts for building with a very slow but high efficient low temperature heating system or high temperature cooling system, like a concrete activation. Finally, we tried to answer the questions: what next steps need to be done to get building automation ready for the requirements of nearly zero energy buildings and to unleash the before mentioned potentials? In case of the required central control function, we think, although central producer independent protocols are already available, these systems have to be developed further to become standard in nearly zero energy buildings. Furthermore, transparency concerning energy demand of control system is required. This can be initialized by producers or should be required by regulations or labelings. Concerning monitoring and feedback, further research at nearly zero energy buildings in operation would be necessary to discover the critical items. Once these critical items are discovered, suitable standard feedback systems need to be developed, which then need to be required by regulations to ensure that finally the climate targets can be met. Concerning individual feedback and control systems, actually only very limited studies on saving potentials of those exist. In case significant potentials can be evidenced, the task of the industry will be to develop simple, effective and affordable systems. Load shifting and storage management. As indicated, the expected potentials of load shifting and storage management are significant, but also dependent from the building type and region. Once the national nearly zero energy requirements are fixed, detailed examinations should be performed to define suitable requirements on that topic. Electricity suppliers should offer flexible energy tariffs that will be for sure a strong driver for building automation controls, which finally will contribute significantly to grid stabilization. Concerning the increase of shares of renewable energy on site, which is mainly PV, the market recognition could be increased by a collection of best practice examples. Finally, within the topic of ensuring thermal comfort for nearly zero energy buildings, we see the necessity of industry to develop suitable controls for slow reacting but high efficient systems like concrete activation, for example by using weather forecasts. So this is my last slide. All in all, although there are still some points to solve and questions to answer, building automation will and have to play a significant role for successful realization of nearly zero energy buildings in the future. Thank you very much for your attention.